So welcome everybody to this latest video on 162 Maths, and in this video we'll be doing a practice paper of the AQA Maths GCSE 2022 paper 1, which is a non-calculated paper. Now there will be a copy of the questions in the description below for you to download and have an attempt at before watching this video and going through the answers. So here on the screen are the list of topics that will appear on paper 1 of the higher GCSE AQA paper. Now in terms of the questions that we are going to be going through in this video, they're not going to include every single aspect of these topics. It's just a small fragment of them. So it's just a case of one possible type of question you could get related to these topics. Now I would strongly urge you that when revising, that you revise the topics, not the questions in certain textbooks, videos or past papers. Make sure you fully understand all aspects of each of these topics. Now, if you've not already attempted some of these questions by downloading the link in the description below, then I strongly recommend that you pause the video while I'm reading the question before I spoil and go through the answer. So for this question, it says work out the value of 2 1/3 squared. Now for this question, I would strongly recommend to convert this mixed number into an improper fraction. So then we've got 2 times 3 plus 1, which is 7. So it's 7/3 squared. And then if I square both numbers, I get 49/9. And I then want to convert this into a mixed number. So how many 9s go into 49? Well, that's going to be 5 with a remainder of 4 with 9. So it's going to be option B. Then looking at question 2, it says the vector -3, 5 translates to A to B. What is the vector going in the opposite direction? So again, if you want to have a go at this question, pause the video. And in terms of this answer, all we need to do to go in the opposite direction is reverse the numbers or the signs of the numbers in the vector. So here we're going from -3 to +3, and here we're going from +5 to -5, and that there would be our back vector. Then with question 3, this is linked with standard form. So again, if you want to have a go at this question, please do pause the video and then let's go through the answer. So for the first question, it says all we need to do is convert this number into to standard form. So this is going to have a negative power because it represents a small number. So it's going to be 8.6 times 10. And then if we imagine the decimal point and imagine that 8.6, then it's just a case of 1, 2, 3, 4. So it's going to be to the power of -4. Then with question B, we're dividing. So again, we're going to split this into 2 fractions. Now 5/4, well, that's going to be 1.2 and 1.25 rather, and multiplied. And then here, what we then need to do is we take away the powers. So that's going to be 10 to the power of 2. And this as an ordinary number is going to be moving the decimal point 2 places. Give us an answer of 125. Then moving on to question 4. So again, sticking with the theme of fractions, it says for the following, give each of the fraction in its simplest form. So again, if you want to have a go at these questions, pause the video and then let's have a look through the answers. So for question 8, we want to write this as an improper fraction, also known as a top-heavy fraction. So again, we do the big number times the bottom number, which is 14, add it to the top, and that then becomes 15/2. For question B, we've got 3 times 3, which is 9, plus 2, which is 11. So it's going to be 11/3. And then for C, we're just simply working it out. Now we're going to use our answer from A and B. So I've got 15/2 times 11/3. So 15 times 11, well, 15 times 10 is 150, plus another 50 is 165. And 2 times 3 is 6. And then all I then need to do is do the division. Now, so if I just do 6/165, 6 goes into 1 none, 6 goes into 16 twice, remainder 4, and then 6 goes into 45, and that's going to be 7, remainder 3, and then we have a decimal point in there, and then it's going to be a 5. I don't know why I've put a 0 there, so let me just get rid of that and change that to a 5. And then we then just need to write this as a mixed number. So here what I've got is I've got 27.5. And there is our final answer for C. And then for D, we then got to work out the division. So for D, we're doing 7.5, which is 15/2. Divided by 3 2/3, which is 11/3. Then remembering the rules of fractions, we flip the second fraction. So it becomes 3 over 11 and turn it into a times, and that's then going to be 45 over 22. Does that simplify? No. So how many 22s go into 45? Well, that's going to be 2, remainder 1. So we get 22 and 122, 122, either one of those. So moving on to question 5. So again, if you want to have a go at this question, pause the video and then unpause as we go through the answers. So it says Amy plays a game with an ordinary fair die. If she rolls a 1, she wins, 2 or 3, she loses, and 4, 5, and 6, she rolls again. When she rolls again, if she rolls an even number, she wins, and if she rolls an odd number, then she loses. And the question is asking us to work out the probabilities of what would appear in P, Q, R, and S. So what we need to do here, and what this question is asking, is what would these probabilities here be? Well, the probability of getting a 1 on a fair die is going to be 1 over 6, and the probability of getting a 2 or a 3 is going to be 2 out of 6, or a third. And then for rolling an even number on a die, well, that's going to be a half, and getting an odd number is going to be a half. And there's our answers simplified and written as fractions. For part B, then it says work out the probability that Amy will win and the probability that she loses. Well, in order for her to win, she needs to either roll a 1 or she gets a 4, 5, and 6 and an even number. So the probability she gets a 1 is going to be 1 over 6. Or means plus, and then we need to work out the probability of getting a 4, 5, and 6, which is a half, times an even number, which is a half. So that's going to be a 1/6 plus a quarter. And then as this is a non-calculator, we're going to write to the common denominator. So that's going to be 2 over 12 plus 3 over 12, which is 5 over 12. So the answer then is 5 over 12. And the probability she loses, well, that's going to be a 2 or a 3. Or she gets a 4, 5, and 6 and an odd number. So a 2 and a 3, well, that's going to be a third, plus, and then a 3, 4, 5, and 6 is a half, times an odd number, which is a half. So it's going to be a third, plus a quarter. And so again, we've got 4 over 12, plus 3 over 12, which is 7 over 12, which kind of makes sense, because what I could have easily done is just done 1, take away that number, and I would have got the answer. So again, we've got 7 over 12, and let me just write that a little bit more clearly so you can see there. So moving on to question 6, this is moving on to a little bit of algebra. So it says, given that a times 70 equals b, work out the value of 3b over a. So again, if you want to have a go at this video, pause the video. Have a go at this question rather. So looking at this, we know that b equals 70a. So what I'm going to do is I'm going to substitute b for 70a. So what we've got is we've got 3 times 70a over a. Now 3 times 70a is 210a all over a, and the a's then cancel out, leaving me with just an answer of 210. Then moving on to question 7, again, if you want to have a go at this question, then pause the video. So this refers to indices. So with question 8, it says write 64 as a power of 4. So how many 4s do we need to multiply to give us 64? Well, 4 to the power of 1 is 4, 4 to the power of 2 is 16, 4 to the power of 3 is 64. So the answer then equals 4 to the power of 3. Now for this, we've got brackets for b, and we multiply out the powers when we've got brackets. So that's going to be 3 to the power of 12. Now for these types of questions, which are very, very popular, what we're going to do here is we need to rewrite 125 as a power of 5. So so 125 can be written as 5 cubed. So then swapping 125 for 5 cubed, we get 5 cubed times 5 to the power of 4 to the power of 7. Now again, dealing with the brackets, we multiply out the powers, so that's going to be 5 to the power of 28. And then when we're multiplying, we add the powers, so it's going to be 5 to the power of 31. Then moving on to question 8, it says, and again, if you want to have a go at this question, just pause the video, then unpause it when you're done. So it says the number of items n made in 1 hour by a machine is given by n equals 30 over t. T is the time in minutes the machine takes to make one item. The value of T changes from different types of item. On the grid, plot the points that would be used to draw the graph of n equals 30 over T for the values of 1 to 4. So for this, what we need to do is we have a value of T and we have a value of n. So this acts as our x and y values. So we're looking for values of T when it's 1, 2, 3, and 4. So for this first one, I'm going to use this formula. So it's going to be 30 divided by 1, which is 30. For this value, I'm going to do 30 divided by 2, which is 15. For this one, it's going to be 30 divided by 3, which is 10. And for this value, it's going to be 30 divided by 4, which is 7.5. So what I then need to do is plot these values. So it's going to be at 30, then it's going to be at 15, which is there, then it's going to be at 10, and then it's at 7.5, which is just about there. And then obviously I can then join those points up, making sure that it's a nice curve going through those points, and that's not too bad. So moving on to question 9. Again, if you want to have a go at this question, then please do pause the video and then unpause when you've done. So looking at this question, we've got root of 5 squared plus 12 squared equals the root of the cube root rather of 64 and a cubed. So for this, what we want to try and do is simplify both sides as possible. And I would say, although that's not the only way of doing this question, it's just one thing that springs to mind straight away. So looking at the left hand side, we've got the square root of 25 plus 144, which equals square root of 169, which we should know recognizes a square number, and that's going to be 13. So the left hand side equals 13. So then looking at simplifying the right hand side, well, we can notice that the cube root of 64a cubed, well, that, knowing the rules of Surds, can be written as the cube root of 64 times the cube root of a cubed. Now 64 is a cube number because that's 4, and we can cube root a cubed, and that just gives us a. So 13 equals 4a, and so therefore a equals 13 over 4. So moving on to question 10, it says that a large rectangle is made by joining 3 identical small rectangles as shown. The perimeter of one small rectangle is 21 centimeters and the width of one small rectangle is x centimeters. And it says work out the perimeter of the large rectangle. So let's first of all notice that x, now if this is x, then this is also going to be x. So that means that the length of one of those small rectangles is going to be 2x. And if I just work round the perimeter of this large rectangle, just labeling across, that's what I get. Now in terms of the perimeter of a small rectangle, well, that's 2x by x, 2x and x. So the perimeter is going to be 6x, and that equals 21. So 6x equals 21, so x equals 21 divided by 6, so x equals, and we're going to divide both numbers by 3, so that's going to be 7 over 2, so x equals 3.5. Now looking at the perimeter of the big rectangle, well, that's going to be 3x plus 2x plus 3x plus 2x, so that gives us 10x. And so therefore 10 times, if x equals 3.5, it's going to be 10 times 3.5, which is 35 centimeters. And there is our final answer. Then moving on to question 11, it says here are 4 triangles. Which 2 triangles are congruent? So which 2 triangles are identical in terms of size? So again, looking at congruency, we're looking for where we've got the same information. So here we're looking for where the 9 centimeters appears on the same side. So in the question A, now it's basically the answer is B and D. Because, and the reason for that is because our 9 centimeter line is on the same line of the 2 angles of 23 and 58, whereas on A and C, they're all on opposite either side of the triangle. Moving on to question 12, and this relates to direct and indirect proportion. So it says S is equal to K over T, where K is the constant. Which 2 statements are correct? So s is inversely proportional to t. Well, that's going to be correct. And the next one is that s is directly proportional to 1 over t. Then moving on to question 13. So this is looking at solving a quadratic. Now, as it appears on the non-calculated paper, more often than not, these will always factorize. So for this, I want to factorize it first. So I'm looking for two numbers that multiply together to give me minus 12 and added together give me 4. So I'm going to say that my two numbers are going to be 6 and 2. So I've got x and I've got 6 and 2. My larger number is a minus, and because the constant is a negative, it means the sign's going to be different. So I've got this, so then x equals positive 6 or minus 2. Then moving on to question 14. So this is looking at sequences, and it says the nth term of a sequence is n and then n minus 8 over the square root of n plus 3. And the question is asking us to work out the sum of the first and the sixth term. So the first term is where I substitute n equals 1. So that's going to be 1 and then 1 minus 8 over the square root of 1 plus 3. So if I simplify this, I have 1 times minus 7 over root 4. So that's going to be minus 7 over 2. So it's minus 3.5. And the sixth term is when n equals 6. So that's going to be 6, then 6 minus 8 over 6 plus 3. And so I've got 6 times minus 2 over the root of 9. So that's going to be minus 12 over 3, which is minus 4. And then I still need to work out the sum. So the sum equals minus 3.5 plus minus 4, which gives me an answer of minus 7.5. So then looking at question 15, it says that patterns are made using straight lines and arcs, and we've got pattern A and we've got pattern B. So it's more rows are added to pattern B so that the number of straight lines to the number of arcs is in the ratio of 7 to 6. How many rows are added? So for this particular question, how we set it up is we look at pattern B, and we've got straight lines to arcs. Now in pattern B, we've got a total of 8 straight lines, and we've got a total of 9 arcs. Now for each row that gets added, I'm going to be adding another 4 to the straight lines. I'm going to be adding 3 to the arcs. And what I want to do is just then see if I can simplify the ratio. So 8 plus 4, so the next row is going to have 12 straight lines and 12 arcs. So they're going to be the same. So then here the ratio is 1 to 1. Then we look at adding another 4, so that's going to be 16 to 15, and that doesn't simplify. Add another 4, so that becomes 20. Add another 3 to 18. Now that does simplify, in which I can simplify that to 10 to 9. Then we add another 4, so that's 24 to 21, and I can divide that, and that's going to be to 8 to 7. Then I add another 4, so that becomes 28, and another 3 to 24, and that then becomes 7 to 6, which is what I'm wanting. So it's going to be after adding 1, 2, 3, 4, 5 more rows. So how many rows have been added? It's going to be 5 rows have been added. And let me just double check that. So that's 1, 2, 3, 4, 5. Yep. And then it says that a different pattern is made by using 20 straight lines and 14 arcs. The straight lines and the arcs are made from a metal. 20 straight lines cost £12. The cost of one straight line to the cost of one arc is 2 to 3. Work out the total cost of the metal in this pattern. So for this, what we need to do is we first of all need to work out what one of the s's are going to be. So here we've got 12 divided by 20, and if I then simplify that, that becomes 6 over 10. So basically one straight line equals, and that's going to be 0.6, so it costs 60 pence. Now it then says that the cost of one straight line, which is 2 parts, so here 2 parts equals 60 pence. So that means then 1 part is going to equal 30 pence. I don't know why I've put an S there, so let's get rid of that. And so therefore 3 parts is going to equal 90 pence. So that's the cost of one arc. So then what we've then got is we've got 20 straight lines. So 20 straight lines, which is going to be 20 times 0.6, which is going to be £12. And how I've worked that, well, 10 times 0.6 is going to be £6, so 20 would cost £12. And then for 14 arcs, well, that's going to be 14 times 0.9, and 14 times 9 is going to be 36, and then 12, so it's going to be £12 and 60 pence. So then the total cost is going to be £24 and 60 pence. Then moving on to question 16, it says that a biased dice is thrown. Here are the probabilities of each of the score. The dice is thrown 300 times. Work out the expected number of times the score will be odd. So again, if you want to have a go at this question before I'll spoil it and go through the answer. So for this, we need to look at which numbers are going to be odd. So it's this probability plus this one plus this one. So the probability of being odd is going to be 0.15 plus 0.25 plus 0.3, and so that's going to be equal to 0.7. So then what we then need to do is do 0.7 times 300. So again, we just need to work that out, and basically it gives us an answer of 210. Then for question 17, so this looks at cumulative frequency. It says here is some information about test marks from 120 students, and all the question is asking us is to complete the cumulative frequency table. So the cumulative frequency is like a running total. So here we're looking for how many are less than 30. So we just add the previous numbers up. So I'm going to be adding 45. So for this one, it's going to be the previous number, which is 49, plus 45. So that's going to be 4. And then 5, so that's going to be not 54, that's definitely wrong. It's going to be 9. So then we've got 94. Then this one's going to be 94 plus 18, so that's going to be 12, and then 11. And then for the last one, that's going to add up to 120. Then for question 18, it says here is a cumulative frequency table. What we actually need to do is to plot this. So again, if you want to copy the diagram, it's entirely up to you. But basically what we're doing here is we're plotting the cumulative frequency value against the upper bound. So we're plotting those values against those coordinates. So the first one is at 10, 5. So 10, 5 and 9 work out to be there. Next one is at 25. So that's at 20. So that's going to be about there. Then we're at 50, then we're at 56, and then we're at 60. And then as we were drawing a cumulative frequency diagram, not a cumulative frequency polygon, we want to join those points up with a smooth curve. So I'm going to start at the top here, and what I want to try and do is make sure that your curve goes through each of the points that you've done. And that last one is a bit dodge, so let's do that again. And yeah, we always want to make sure that you are going through each of the points, and it should look something that looks like that. Then question 19 says this cumulative frequency graph gives the test marks of 60 students. Students who scored 15 marks or fewer take another test. Use the graph to estimate how many students take another test. So for this, we need to find 15 on our horizontal axis, so that's there, until it hits the curve. And then once you've got that, you then want to project horizontally, and it's this number here that we're wanting, which I work out to be 16. So 16 people are going to have to retest. Now if it was how many people didn't have to retake, then I would take 16 away from the grand total, which is 60. Then for question 20, it says here is a tunnel for a toy train, and it says the diagram below shows the cross section of the tunnel, and it says AD is the semicircle arc of radius 10, BC is the semicircle arc of radius of 8 centimeters. The length of the tunnel is 30 centimeters. Work out the total area of all 6 faces and the tunnel. So let's start by labeling these. So I've got A, I've got B, I've got C, and I've got this is going to be a D, and this is going to be a D. Now in terms of the area of A, well, that's going to be this shaded area here. That's what this is here. And that is the sort of area of the big semicircle, take away the area of the small semicircle. So it's going to be pi times the radius of the big semicircle, which is going to be 2 plus 8 plus 10. Well, it's going to be 10 basically. So I've got 10 squared divided by 2 minus the sort of area of the smaller semicircle. That's pi times, and then half the radius is going to, well, the radius is 8. So that's going to be 8 squared divided by 2. So working this out, I get 50 pi minus, that's going to be 32 pi, and that gives me a total of 18 pi. And the area of B, which is a rectangle. Now, the length of that rectangle, the height or the width, whichever you're looking at, is going to be the circumference or half the circumference of that top rim of A to D. So here what we've got is it's going to be 2 times the radius, which is 10, times pi, divided by 2, times the length, which we know is 30. So simplifying this, we get 2 times 10, which is 20, divided by 2 is 10. So that's going to be 10 pi times 30, which is 300 pi. Then for area C, which is this underlayer, so that's going to be 2 times 8 times pi divided by 2 times 30. So that's going to be 16, 8 pi. So it's going to be 8 pi times 30, which is 240 pi. And then for area D, which is just a rectangle, which is these two little strips here, and that's going to be 2 times 30, which is 60. Now in terms of how many of these I've got, well, I'm going to have 2 lots of D, so I need to times that by 2, which gives me 120. And so here we've got 1, 2, 3, 4, and which one am I missing? Well, I've got 2 of those, so I need to multiply that by 2. So then here, that's going to give me 36 pi. So then the total area is going to be 36 pi plus 300 pi plus 240 plus 120. So adding all of these up, well, I'm going to get 576 pi plus 120 centimeters, and there is my final answer. Then moving on to question 21, which is looking at Venn diagram. So again, if you want to have a go at this question, please do pause the video and then unpause to go through the answer. So this Venn diagram shows information about some houses. G represents the houses with garages. S represents houses with a shed. And it says a house is chosen at random. A house has a garage. What is the probability, written as a fraction, that it has a shed? So we know it's got a garage. So our total is going to be 14 plus 9, which is 23. And out of those 23, how many have a shed? Well, that's going to be 9, and I can't simplify that, so that there is my final answer. The next question then says that house does not have a garage. So how many do not have a garage? Well, that's going to be 14 that don't have a garage. And the question says, what's the probability that it does not have a shed? Well, how many of those don't have a shed? Well, that's going to be 3 out of 14. The next question is all about shading the diagram. So here it says, what is the probability of G and not S? G and S, well, the not of G and S. So this is, G and S is this bit here. So what's the probability of not having that shaded area? Well, that's going to be out of the total of 20 of all of the answers. So let's just work out how many there are. So I've got 14 plus 9 plus 11 plus 3, giving us a total of 13, 14 and 17 and then 37. So out of the 37, I've got 14 plus 11, which is 25, plus 3, which is 28. And then from the next one, which is the probability of G or not S. So what you want to do here is shade these in separately. So probability of G is this, and the probability of not S is this. Now what I'm wanting is, because it's all, I want all the areas that are shaded, so that hence why I've used the two colors. So not S would actually be this. So I want all the numbers that are colored in, which is going to be everything apart from 11. So that's going to be 26 over 37, and there is my final answer for that one. Then moving on to question 22. So here we're looking at reoccurring decimals. So it says work out what 0.5036 take away 0.01. Well, for this, all I'm doing is lowering that number by 1. So it's going to be 0.5026 recurring. And then that's going to be a 3, because obviously this number here is 0.5363636. And if I take away 0.0010000, and those 3 6s are going to continue. So this is the number that I'm wanting to find, which is option C. Then for question 23, it says here are the first 4 terms of a quadratic sequence. Work out the expression for the nth term. So again, if you want to have a go at this question, please do pause the video and then unpause when you're done. So from this, what we want to do is, we know it's a quadratic sequence. We need to work out the double difference. So if I just write down the numbers first. So here the difference is 11, then it's 15, then it's going to be 19, and then the double difference is +4 +4. So that means then the double difference is 4, so that means 2n squared is in the formula. So from this, we've got, now whenever you're dealing within sort of quadratic sequence, you may do it differently. So I've got n squared equals 1, 4, 9, 16. So 2n squared is therefore going to be 2, 8, 18, and 32. I then want to compare that to the numbers in the sequence. So I've got, if I write sequence, I've got 10, 21, 36, and 55. So then what I then want to do is work out the difference. So the difference here is to get from this to this is it's +8. Then it's going to be plus, and that's going to be plus to 13. Then it's going to be plus to another 18, and then plus 23. So what I then need to do is treat these numbers like a linear sequence. So here the difference between these numbers is 5. Oh, so that means I'm going to have 5n in the formula. So that's +5, +5, +5. So the nth term of the difference is 8, 13, 18, 23. So then it's going to be 5n. And then what do I have to do to get from 5 to 8? Well, I need to add 3. So this is the nth term of the difference. So I just need to combine this with this, giving me an nth term formula of 2n squared plus 5n plus 3. Then moving on to question 24. And again, if you want to have a go at this question, pause the video, then unpause when you're done. So it says -212 is the point on the line P. 5, 0, and 7, 12 are points on line Q. P and Q are parallel. Work out the equation of line P. Give your answer in the form of y equals mx plus c. So first we need to do is find the gradient of line Q. Now we do that by looking at the difference in the y ordinates, which is 12, over the difference in the x ordinates, which is 2. So then that's going to have a gradient of 6. So that means that m equals 6. Now from this, I'm then going to use this coordinate. So I've got y equals mx plus c. I know that m equals 6, x equals -2, and y equals 12. So substituting those numbers, I can then work out what c is. So I've got 12 equals 6 times -2 plus c. So I've got 12 equals -12 plus c. So c equals 24. And then combining these two, I get y equals 6x plus 24, And there is my final answer. Then moving on to question 25, it says ABC and ACD are triangles. K is a constant. Work out the vector of C to D. So to get from C to D, I need to go from C to A plus A to D. Now C to A is going in the opposite direction, so that's going to be equal to minus 3B. And then A to D is going in the correct direction, so that's going to be 8A plus 7B. And if I simplify all of that, I end up with 8A plus 4B. It then says that BCD is a straight line. Work out the value of K. So BCD is a straight line. So first of all, we know that this is 8A plus 4B. And we know that this, or to get, let's first of all get the arrows in the right direction. So this is that. So then this B to C is going to be equal to KA or AK plus 3B. Now, if they're on a straight line, then basically what that therefore means is that BC is going to be a multiple or a factor of 8A plus 4B. Now, looking at the diagram, although it's may not be drawn to scale, I'm guessing that CD is bigger than BC from what I can visually see. So then what we're looking for is to find out the scale factor. So here the scale factor comparing these coefficients is that the scale factor is going to be 4 over 3. So then to work out what K is, I need to then do 8 divided by 4 over 3 because I'm going from big to small. And then that then becomes 8 times 3 over 4, which is 24 over 4, which is 6. So K equals 6. Then moving on to question 26, which looks at surds. And so what we want to do is we want to write this in the form of C root D over 10, where C and D are integers. So first things first, what we want to do is get a common denominator. Now, a common denominator here is going to be, well, I think probably is going to be root 50, I would suggest, is probably the most common route that most students would go. So I'd multiply this by root 5 and root 5, and I'm going to multiply this by root 10. Now, it's not the most ideal route. I'm sure that we'll be able to simplify this further. So let's have a look. So here we've got root 15 over root 50 plus, and then that's going to be 3 root 60 over root 50. Now, in terms of simplifying each of these, well, we know that root 60 can be written as root 15 times root 4. So that becomes 2 root 15. So then what we've then got is root 15 plus 3 lots of 2 root 15 all over root 50. And then that then becomes root 15 plus 6 root 15 over root 50. Then this then becomes 7 root 15 over root 50. Now root 50 is root 25 times root 2, and then that then becomes 5 root 2. So from this, what we've then got is 7 over root 15 over 5 root 2, and I feel as if this question is going to be going on forever, and I'm sure that there's going to be a quicker way of doing this. So then from this, what we've then got is we multiply both the top and the bottom by root 2. And so what we get is 7 root 30 over 5 root 4, which is 7 root 30 over 10. And that is the form that we're wanting. So here what we've got is we've got C equals 7 and D equals 30. And we can't simplify root 30, so that there is going to be our final answer. Then moving on to question 27, again, surds again. So it says, write root 80 in the form of a root b, where a and b are integers less than 10. So here we've got this as root 16 times root 5. And so that's going to be 4 root 5. And there's our final answer. For b, we want to write this as an improper fraction. So we've got 20 over 9 square rooted. Now for this, what we then want to do is potentially write this. We can write this as root 20 over root 9, which is root 20 over 3. Now in terms of root 20, I can write root 20 as root 4 times root 5, and that's going to be 2 root 5. So what this is then going to become is 2 root 5 over 3, which is 2 over 3 root 5, and there is my final answer for that one. And then for C, all we're going to do is just join our answers in part B, A and B to work this out. So root 80 I can write as 4 root 5 plus, and I'm going to write this as 2 over 3 root 5, which then becomes, and if I just add these together, I get 4 and 2/3 root 5. And then what I then want to do is write this as a improper fraction. So 4 times 3 is 12, plus 2 is going to be 14 over 3 root 5, which is also 14 root 5 over 3. So D equals 14 and E equals 5. Then moving on to our last question. So this all involves exact values of trig. So for this, it's just a case of knowing what these ratios are. So recognizing that root 30, sine cos 30 is root 3 over 2. Tan 60 is going to be root 3. And sine 30 is a half. Now, knowing these, what we're then going to do is substitute this into our answer for part B. So sine 30, we're going to use a half, plus tan 60, which is root 3, plus, or times, I should say, cos 30, which I've worked out to be is root 3 over 2. So what we want to do first is combine these two things here. Now, if I turn that into a fraction, then what I end up is with a half plus root 9 over 2. Now, root 9 over 2 is a half plus 3 over 2, and that then equals 2. And there is my final answer and the end of this mock paper.